Kia kotahi, kia kaha, kia pakari. Tihei Māori ora. No mai, haere mai, e ngā hau, e whā, whānui. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Hello and welcome to today's Spotlight webinar coming to you from a variety of locations around Aotearoa, New Zealand and Australia. Thanks for joining us. My name is Philippe Boulanger. I'm a product commercial partner in the Spark IoT team and your host for today's session. Before our speakers get to their presentations, I'd like to go through a bit of webinar housekeeping. For starters, you can ask a question at any time during the webinar. Simply type your question in the question section on the right-hand side of your screen. We'll be answering those at the end of the session. And please also remember to upvote a question that you'd like to have answered that someone's already entered. And during the session, we'll also be running a poll, and we'll be putting that up halfway through. So please have your say, and we'll share the results at the end. And also a final note that this webinar is being recorded and you'll have access to that after the session. Right, let's get on with things. So we're going to first hear from Nish and then Gerhard, and then both of them will come together to answer your questions at the end. So for an introduction on Nish Dogra, he is an accomplished engineering professional with over 9 years experience in the water sector and 7 of those with Watercare. And he's been with Watercare over a variety of roles, including a network engineer, special projects engineer, senior network planner, smart water specialist, and is currently their smart network lead. Nish has successfully delivered multiple smart technology pilot projects and has been involved in delivering the largest AMI project across New Zealand. This project has incorporated 4,500 commercial smart meters and 44,000 smart residential meters. He has also acted as a key subject matter expert to create end-to-end smart metering infrastructure processes and also standard operating procedures. Quite the bio. Nish, I'd like to welcome you to the stage, and it's a pleasure to have you join us.
Thank you, Philippe. That does sound like a mouthful. Good morning, all. I'll be presenting on how technology is helping us improve water management based on our experiences, especially from last 2 years on various projects we've been working on. I would like to start with letting everyone know why we do water management and why water is an invaluable source for us. Now, water may be the most common substance found on Earth, but even less than 1% is available as fresh water for us to consume. And out of that 1% as well, there's a fraction of it that we can actually easily utilize. And as we all know, to say the obvious, all human plants and animals need water to survive. So there's a lot of demand and not enough of it. Based on some recommendations that we've got from around the world, it takes at least about 50 liters per day to meet one person's basic needs. Half the world's population is currently surviving on 95 liters per person per day. But in places like New Zealand and Australia and other industrial countries, we have more than 200 liters per person per day. Quite a lot, almost double than half the population, what they've been getting. So from our perspective, we do think we have a lot of water and we use it as we want to. But regardless of that, in some water-stressed countries, there's people who survive at 10 liters per person per day as well. So that's the condition of water, and that's why we need to manage the amount of water we have. So what caused us to think a lot of water management while we think we have a lot of water and we've been using double the amount of half the population of the world? It's the extreme weather events which have made us rethink the way we use our water. In 2020, Auckland went through a very big drought, which made sure that a lot of our dams, they were at the lowest capacity in the last 25 years. There was hardly any water, hardly any rainfall. And from some of the pictures, you can see some of the dams which were quite full most of the times, because in Auckland we get a lot of rainfall. We're getting no rainfall at all, and they went down quite a lot. In certain cases, we even saw a lot of things which we haven't seen for many years under the dams, and we found a lot of new things as well, like soft tunnels, old rail tunnels, and a lot of other land events. But a lot of the times we think the water scarcity is only caused by extreme weather events, which are like droughts or summers or no water. Sometimes water scarcity can also be caused by other extreme events, such as the recent one we had. We had a lot of rainfall. We had landslips, and a lot of our dams were so filled with silt, it got really hard to clean the water and ensure that then demand for the clean water is met because the treatment plants were working at a lower capacity than normal. We also had a lot of slips, which caused some of our large trunk mains to be broken, and water was leaking down the hills rather than flowing through the pipes. And that caused further water shortages. So while a lot of these extreme events might cause for us to think why we need to manage our water and why we need to be efficient with the water, a lot of the things we do are as a reaction of these events, not a proactive measurement. And the reaction of this was what Watercare started doing after we had those droughts. We ran a lot of water-saving campaigns, asking people to save water, telling them why water is precious and they should be saving it, giving them ways to save water. We also had water restrictions in place where we were asking people to save water. There were a lot of restrictions where people couldn't wash their cars, couldn't water their garden, and a lot of restrictions were also placed on the large commercial consumers. Luckily, during that time, we were saved with COVID-19 restrictions as well. So a lot of industrial customers were not operating at their highest peak, which helped us manage this drought slightly better than we could have been otherwise. So the problems we had, the first one and the most important one that I would say is lack of timely information. And everything that's below it kind of ties back into it. The lack of timely information is very crucial when you're managing a drought on a daily basis and trying to understand how much your consumers are using, how you manage your demand, how much your large consumers are using. So the lack of timely information was the major problem for us because I'm not sure if many of you know, Watercare does meter all of its customers. A lot of our large commercial consumers are metered on a monthly basis. So that's when their meters are read every month, once a month only. And a lot of our residential customers' meters are read bi-monthly. So every alternate month is an estimated bill. So you won't know how the behavior is changing for 2 months for residential and almost a month for commercial customers. The second problem we had was customer trust. A lot of our customers sometimes do not believe when they have private leaks and they get large bills that Watercare is billing them fairly. So that lack of trust has always been there because a lot of people don't believe they have private leaks, even if when they have 100-year-old, 75-year-old pipework sitting in their houses or in their complexes. Other problem we had was lack of digital twin. So while you're trying to manage a drought or any other operational problem, you need a digital twin where you can do some desktop analysis to understand how you solve your problems or what problems you have or what are your worst case and best case scenarios based on water modeling. But a lot of the times, water models are way off compared to what's happening in the ground. Over time, the networks change, the pipe and the valve configurations change, but not all of those are reflected back into a water model. Having a lack of digital twin was also another problem which we didn't have. Leaks, both private and public. So as I advised, a lot of customers may have private leaks, which we or they might not know about. A lot of the times people think it's just excessive usage they've done. If it's 10 to 20 liters a day, a lot of people don't even notice that over time. And for a lot of large consumers, sometimes the leaks could be very large. But then again, on the larger scale of things, the way they consume water, it could be ignored as well. But over time, all of that water does account to a lot. Public leaks was another important issue we had. While Watercare was gearing up, asking people to save water, it is not a nice look when our own leaks are leaking for months or days while we're asking people to save water. It does not reflect well. And we need to lead by example as well. So leaks were another problem. And last but not the least was demand forecasting, which again ties back into the lack of timely information. While you're managing a drought or incident, you need to manage your demand on a daily basis. A lot of the demand currently is based on assumptions, based on the average data we've got, but not on the live data we're getting from the smart loggers. So these were a few of the problems we had. And the solutions were smart loggers. Now, in this case, smart loggers that we are referring to are just the loggers we're putting on large commercial meters. But smart loggers does include all of our residential smart meters. It includes pressure sensors, acoustic sensors, transient sensors that we put in the ground to understand how the pipes are operating, and every other smart logger we put to understand what the operation is happening in the ground. So the solution that the smart loggers provided us was improved transparency. So with the smart loggers, we could get, for example, in this case, with the Cactus logger that we were using for the commercial customers, was getting 15-minute data pushed once daily. And that data was also shown to the customers by the way of a web portal. So they had access to the data, and they could actually use something and go look back the next day at the same time of how much water they've used. That created a very transparent consumption profile. And they could have a lot more trust within us. So that did enhance the customer trust as well, because they knew that what they're getting billed for exactly what they're using, because they can see that granularity for the first time. It also helped us do a lot of proactive leak detection. Now, the leaks I'm talking about here are the private leaks. Now, a lot of these consumers have large meters, and you can see from the pictures, some of these large meters could be 100 mil, 200 millimeters, ranging all the way from 50 to 200, to be honest. And these are large complexes, and a lot of the meters are also under large metal pits. So these leaks, when the customers have private leaks in these large consumption properties, these could be thousands of liters a day. And it helped us a lot to pick up those leaks as soon as they happened over the 3-day time period. If we could figure out that's a leak, we were informing the customers that they do have a private leak. And then they did proactive steps to find the leak and fix it. And then we could see the effect of fixing the leaks straight away as well, because the consumption profile when the nighttime, especially when they're not operating, did drop once the leak was fixed. So proactive leak detection was another benefit we got. We also got to educate customers to become more water efficient. A lot of customers over time, especially industrial customers, they want to save water over time. And this is a new drive that didn't just start out of a drought, but a lot of people are trying to be more water efficient as part of their green, clean image. So a lot of the customers wanted to be water efficient, but they couldn't because they did not have access to the granular data. With the use of these smart loggers, we could provide them that data, and they could be more efficient to understand which processes are using the most water and where they could save water. It also helped us complete water and wastewater audits for some of our customers. And demand forecasting. As I said, the large consumers play a huge role in helping us understand the demand for a water supply zone. So once we started getting this data on a lively basis, we could understand exact profiles during the day, peak times, off-peak times, and night times. So that helped us improve our demand forecasting a lot as well. And again, as a result of that, because we're getting that granular data, it improved our water models as well. Accurate night flow analysis, it's one of the most important from my perspective, because that's where your business case lines up for cost-benefit analysis. A lot of the times we spend a lot of our efforts looking for leaks in a water supply zone. And the way we find leaks, the historical way of finding areas where we would focus our efforts to find leaks would be look at the zones which has the highest night flows, because people should be sleeping at the time, not using water. And if it's a lot of night flows, we probably have a lot of background leaks. Now, what this did was it helped us improve where we focus our efforts, because we knew exactly some of these large consumers who were 24/7 operators. We could understand how much water they're using in each zone at the time, and we could deduct that from the night flows as a legitimate water use. So we could start focusing on a lot of zones which we were previously focusing on when a lot of water from the night flow was contributed towards the actual usage. And we could start focusing on where the actual night background leakage was. So those were a few of the solutions we got. There were a lot of challenges we came across while installing these devices. Initial procurement challenges was one, trying to decide which device to go with. There's a lot of products out in the market. Choosing the one in sense of the device and which communication provider you go with has been a challenge. I'll be honest, Spark was quite good to work with us. I've worked with people from Spark, like Matt McLean, and we helped each other a lot in terms of improving the network coverage over time. So we started with Cat M1 devices, and we slowly changed them over to NB-IoT devices as the network improved, and it has improved a lot in the last 1.5 to 2 years. So initial procurement challenge was there. Upskilling existing contractors was another one. So this is in regards to your other sensors, likes of putting pressure sensors, making sure you're maintaining them, your initial residential smart meters. You need to let your existing contractors know how to install them, how to commission them, how to ensure they've successfully commissioned so you can start utilizing the data. So upskilling the existing contractors was one of the major issues we had. We created a lot of new SOPs to train them how to do things, to what to look for, how to take photos, how to install things. And also engaging new contractors. In this case, we did use help of Arthur D. Riley to install Captus loggers on our large commercial users. From some of the pictures, you can see it requires a lot of wiring. So you need a specialized workforce to install these Captus loggers when you're installing pulse units and connecting them back to the logger unit. Connectivity and other meter issues. So from the pictures, you can see some of the existing meters are in a very not so great locations. Sometimes these are deep pits under fancy pavements. Sometimes they're underwater. Sometimes you have damaged meters, which you need to install on, or sometimes customers damage the meters after the device is installed. And the last picture is not just an ice cream picture. It's actually where one of our meters is hiding somewhere. So it required a lot of effort to find some of these meters which were not read because of the access issues, and we wanted to install loggers on it for the first time. So a lot of teething issues to start with, but then we got hold of it and we know what to look for going forward. Data analytics and distribution was another major issue. A lot of these loggers, the amount of data they send you is a lot. I'll give you an example. A smart meter, residential smart meter, based on 30-minute intervals and sending once daily, and including all the alarms that it gives, could send up to 50 data points per meter a day. And if you have about 40,000 meters in ground, you're sending about more than 2.5 million data points. That's a lot of data points to work with. And it took our data scientists a long time to realize that and start looking for the tools that could analyze that large data. So data analytics was one of the major issues we came across. And over time, we've learned and we've got the right tools to work with now. Distribution is another issue we're still working with. A lot of consumers are fine seeing the data in the web portal and downloading a file once off to see how their consumption is being used, or consumption profiles being looking like. But a lot of the customers do have companies like ESP and like some other companies which help them run their efficiency numbers for both power and water. And they wanted direct API access into our data cloud, so they could get daily output of the data and send it directly to their contractors who are working with the efficiency numbers. So that is something we're still working with. And we're working on an API system where we could provide on-demand data to these customers, sending it to the third party of their choice once they approve, so they can analyze their data and can get a live feed of the data as well as it comes to us. Operational data ingestion, we're still working on this. Operational data ingestion is very important for us to stack back to our business case and provide the cost-benefit analysis. Operational data ingestion mostly reverts back to the night flow analysis. So while we've been doing it for a few zones, we're not doing it at large scale right now. So operational data ingestion is a good challenge to look for and start utilizing this data to improve your daily operational use case, such as looking for non-revenue water, focusing your non-revenue water efforts in right places at the right time. So the learnings we had and the future roadmap we're looking for. So the device connectivity learnings was one of the major ones, commissioning and ongoing connectivity. So commissioning a lot of these meters the first time is a problem sometimes. We'll also give an example, some of our residential smart meters. So a lot of the times, the first gen of those meters is you need to commission them using a certain very simple steps on the meter. But going forward, we've had those learnings that sometimes it may not be followed properly because contractors will not always follow SOPs. Going forward, we're trying to get the meters which are auto commissioning, or if the commission itself, once the commissioning process is started, so there's no truck roll or manual truck roll back again to the site. Ongoing connectivity, again, we're feeding this data back to Spark, likes of Spark and other mobile providers, in terms of if there's meters who are not connecting properly, we either if it's out of the coverage area and not providing enough coverage, we are feeding that data back to our telecom providers to ensure they can improve their network coverage over time. And also, if it requires an external antenna to be installed to boost the signal, we've been doing that as well. Data ingestion, as advised, a lot of data, and you need specialized analytics tool to work on. So that's good learning for us, and we've already procured a tool to ensure that we can ingest all of that data and work with it. But anyone starting from scratch, I think it's a good learning to ensure that you have the right tools in place to ensure you can work with the amount of data you're going to get once you install these devices. Focus on value streams first to substantiate key savings. It's again ties back to trying to get operational value out of these devices first, rather than just trying to get the billing data out. Billing is, yes, one of the important aspects, but trying to get all the alarms out of it, trying to pick up private leaks, trying to pick up the night flow analysis, that's one of the major value streams in my eyes. And I think that's where we should focus first to substantiate key savings, dollar savings, which you can then take back to your financial approvers and ask for more money to continue installing these devices. New and improved devices, the market's changing a lot. Since the time we started, I think there's a lot more devices now in the market, both in terms of loggers and smart meters. So things are improving a lot. The market's still expanding. IoT is still fairly new in our part of the world in terms of water sector, but things are improving a lot in the last 1 or 2 years, and there's a lot more devices. So constantly looking for new and improved devices to ensure we're utilizing the learnings we've had so far. Customer web portal is something we're working on. Right now, we are utilizing a third-party customer portal to showcase the data to the customers for our CapEx loggers. Going forward, Watercare is thinking of building their own web portal so customers can have access to that data. And again, we're working on this API as well to share the data with the customers or their contractors if need be. And operational utilization of smart logger data. I think it's a repeat again. That's a key thing which I'll keep repeating again and again because that's where your major value is. Customer contribution to fund the logger deployments where possible. So ever since we started deploying these loggers, there's been a lot of interest from a lot of customers who don't have this logger or who were not part of the phase 1 or phase 2 installs. And they're very keen to get these loggers on as well as part of their efficiency drives. So in future, we are thinking if it's possible and customers are more than happy to contribute a small amount of full amount for the logger, which may be a very small value for them, and it gives them 7 to 10 years of data coming to them. So that's something we're looking at as well, and which may also help us looking at the financial side of things to understand how much contribution we need from our own utility versus how much contribution can customer provide. And that stacks up your business case a lot well, and you can get capital for it for your future projects. So that's all the learnings and future roadmaps we've had so far. Thanks, Philippe.
Thank you very much, Nish. So great to hear, obviously, the challenges faced and the approach taken, and obviously a great insight into the what's next. So I'm sure some great questions coming at the end on what was said. And that's a reminder to everyone listening, in the questions tab on the right-hand side of your screen, please enter in a question that you'd like asked of Nish or Gerhard, who will be introduced shortly. And also have a review of the questions there to upvote any that are of interest to you that have already been asked. So thanks again, Nish, very much. And before I invite Gerhard onto the webinar stage, one last thing from me. There is a poll we're running on the session, so I'll just bring that up for everybody. It's a chance for you to have your say. The question is, how can we solve future water crises? The question there and the answers, finding new sources, managing existing resources, reducing the demand, or don't do anything, we've got enough. So please have your say and get to that question when you can. So now to introduce Gerhard Loots. Gerhard is recognized as a thought leader in IoT and digitization after many years of leading and transforming businesses across multiple industries. He excels at bridging the gap between the commercial product development and the technical understanding. That helps to strategically identify and deliver growth initiatives, leveraging digitization to generate new business value. So prior to joining Kallipr in 2021, he held the global head of IoT position at Telstra, where his team established software development capability, acquired new capabilities, established international relevance, won multiple industry awards, and drove growth in excess of industry. He also served as a member of the GSMA's Global IoT Steering Group and as a non-executive director of MT Data. So Gerhard, pleasure to have you with us, mate, and the webinar stage is all yours.
Thanks for the introduction, Philippe, and good morning, everyone. And Nish, also thank you for that presentation. It's always interesting, hearing about the problems that we encounter when we do these things. We're using the word digitization quite a lot, and I thought, well, it might just be worthwhile for us just to stand still there on a moment before I get into the presentation and just talk about what it is. When we consider digitization, it's effectively the process for us to get rid of paper and manual human processes to move towards more data-driven or data-informed decisions that ultimately ends in automation. Now that's a mouthful, but when we think about things like the humble traffic light, the first traffic light was put in place in London in 1868, which is a very, very long time ago. Cars weren't even around at that stage. But it was done to replace the human being who was standing in the middle of the intersections, and that there was obviously health and safety and efficiency concerns when we look at that. That moved to, from the health and safety initial use case, it then moved into an automation use case where they started using timers to switch the traffic lights, between the different colors. But ultimately, when we think about that process today we expect the traffic light system to ultimately manage the resource of road better, so that we can ultimately reduce the wastage of which is the time we spent in traffic today. And I think there's a lot of analogies and consistent things to consider between that little story and what's happening in the water industry. So from our perspective, we just wanted to sort of talk a little bit about where to start the digitalization journey and what we've seen across different industries, and then also some of the lessons that we've learned specifically in the water industry itself. As an interesting little tidbit, that picture at the back is not a real picture. That was generated using AI. And I'll touch a little bit on AI at the end and the importance that we see it playing for us in the future. Excuse me. Look, I think as a starting point, when we talk about digitization or making a business run better, the first thing is essentially to understand the business challenges. Even in the water industry, we work with a number of water utilities across different countries, and the challenge is different. The challenge is different in Christchurch to what it may be in Auckland. It's different in Sydney, and I think the key thing for us is to say what we always say to a customer is just start off with listing your problems out and understanding why you want to solve them, because that essentially informs the second phase for us of it, where you now have a list of all the challenges that you're trying to solve in your organization, and then you have to do risk reward trade-off. When we think of the work that someone like Nish has been leading inside these organizations, it's a very difficult thing to do. There's transformation that needs to take place. You've got to take the organization along with you on a journey. And ultimately, in order to convince people to change, you need to show them proof points. So when we think about a risk and reward trade-off, it doesn't always necessarily make sense to grab the biggest problem. You've got to trade off the biggest problem with the time it might take to solve it, and then try and prove along the way that this digitization journey that you wish to lead the organization on is working. So once you've got that, though, you can then start this continuous improvement journey. Now, when we think about continuous improvement, a typical Six Sigma process says define, measure, analyze, implement, control, and then you start on the next problem every time again. So but I think it all starts off with just understanding the business challenge. And when we think about business challenges, when we start working with new customers, apologies, I've just got something in my throat. When we think about business challenges, one of the first things we try to understand as the measuring tool at the edge, essentially, is to understand the use case, but also the operating environment. That's a photo of an overflowing sewer. The gases and the chemicals and the acids contained within that water is tremendously abrasive and toxic. Some of the gases in there can literally kill us as human beings. So you've got to actually consider that at the starting point with the device that you put down there, right? So even things like the plastics, the termination points, the antennas, they're all affected by this. And when we talk about digitization and we talk about measuring things in new places, when we consider the fact that we've got a measuring tool connecting over a network, which typically has more points of more redundancy in it than a single point in a drain or wherever it may be, and then you move up to the cloud, most of the weakest link in the chain at this point becomes the device that's sitting in there. Nish also spoke about how challenging it was to get the right device, but then on top of picking the right device, making sure that device is fit for purpose for the use case and understanding that operating environment deeply. On top of that, you then also have to make sure that as you start thinking at the next phase, okay, well, how do we go about now doing this? From our perspective, we always recommend to first trial. Trial is really important. Trial allows you to understand the operating environment a little bit different, a little bit better. There may be variances in previous experiences that we've had or that you've had that needs to be highlighted and taken into consideration. And once you've theoretically proven the fact that you can solve this problem once or twice, the incubate stage is really important. We typically recommend at least having 100 to 200 type devices in the field during the stage. And during that incubation phase, what you're essentially trying to prove to your organization is that the business case that you're trying to solve, the problem that you're trying to solve, once you've identified that you can solve that consistently and that the business case plays out. That incubate phase is very important. At that stage, you're trying to gain the trust of the organization. In contrast to trial, where I suppose you're trying to gain your own trust and trying to gain your trust in the vendors that you're working with. Going back to the commentary that I made about the device being the weakest link, our product needs to evolve consistently too. That's a little photo of our assembly line over in Brisbane, and what we're seeing playing out as some of our customers are starting to scale now is just really controlling more things so that less things can go wrong. And when we look at plug and play solutions, one of the key things that we're working on today is to make sure that when we plug that sensor in, that the device actually know what sensor it is. Device staging is also massively important. We've got a customer at the moment where we're scaling from 8,000 devices in field to over 20,000 devices in field. You look at 15,000 additional devices. What happens in that instance is you've got to process that 15,000 times and make sure that the failure rate is at an acceptable level, because anyone who says that they don't have failure in manufacturing, it's just haven't done enough manufacturing really from my perspective. So you try to make sure that the staging, and what I mean with staging is, okay, how do we make the install as easy as possible? How do we make sure that the installer has the right kit, has the right sensor attached to it, the cable is the right length for that specific installation. The antenna, for argument's sake, is the right length and it's going through the right manual. All of that makes it easier at the end of the day for the installer to install the product and to ensure that you're getting those insights from these new points in your infrastructure. So that's really something that we believe is going to play a more prominent role as we scale, and as utilities such as Watercare starts moving towards massive deployments in the hundreds of thousands. The next phase, though, is this installation component. That's a relatively simple install that we've got down there. So that's showing a meter essentially being digitized by that Captus device, reading the pulses that comes off it. But you've got to make very, very sure that your installation partner also understands the actual device that they're working with. In many instances, the companies we work with are companies that are used to work with something like water infrastructure, which is very logical. They haven't necessarily installed antennas. They haven't necessarily dealt with digitization. So a big part of what we do with our customers is to ensure that our installation partners are trained up correctly. And then, of course, you've got to make sure that you've got the checks and balances on your side if you're the utility or end user, to make sure that installation was done in the right manner. And the reason why that's important is multifold. When we think of the three biggest things that we try to solve as an organization, as Kallipr, we try to increase battery life, decrease the cost of maintenance, and decrease the cost of deployment. Because what happens is when we think about the deployment of these devices, it's no longer just 10 or 20 devices. We're talking thousands of devices. A 5% incorrect installation could literally mean thousands of trucks that needs to go out to go fix something again. And ultimately, that might actually end up in the business case not standing up. So when we think of something like battery life, antenna and signal strength is massively important. If the signal, for example, is weak, the device has to work harder. If the device has to work harder, the battery has to work harder. If the battery is working harder, your device's lifespan on the battery decreases. Similar to that, and that's all affected by things like ensuring that the device is installed the right way, that the antenna is installed the right way. And then on top of that, also obviously making sure that the connection and the cabling and everything that goes in there is secure and can last. So if that fails, especially when you're in the tens of thousands of devices, it's tens of thousands of replacements that needs to take place in some instances, which is not in anyone's interest. It's we want to make sure that we do it right the first time. So you've identified your problems. You've considered the places where you need to install. You've considered the bigger picture. But I think the biggest thing that we've seen consistently across all the different industries that we've been involved with has been what do we do in terms of change management? We have to understand that firstly, this is not just a change in the operational area, but it's a change for the entire organization potentially. If the end goal of digitization is to automate more things, it can have impact on your field force. It can have impact on the way that you legally engage with them. So I think the first thing that we always talk about is just start off with your strategy. Start off with, what do you need to do? How are you going to measure these things that you're going to do, and get agreement on that? Like it's there's a vast number of stakeholders in all these organizations. They need to be involved, and they need to agree with you that these are the benefits that we're expecting if the product, if the deployment is going to go from just a trial to scale. And then data, the Nish gave some stats there around just the sheer volume of data that is getting in, and we see that increasing. We're talking to a customer at the moment who's looking at deploying 4 million sensors. Now, if those 4 million sensors logs every 15 minutes, we times that with 4 to get to an hour, so that's, and then we times it with 24, we're talking about 96 data points across 4 million devices. And that's what I'm trying to do the maths on the fly here, but that's 384 million, if my maths is standing up, data points that all of a sudden that customer is going to try and manage on a daily basis. And there's very few companies in the world that's ever had to do that. The telcos are in a good position. They typically deal with that type of data on a daily basis. And then your Microsofts and Amazons and large companies have dealt with that type of data. But most other companies have not. So I think the first point is get that data strategy right. Get your compliance right. Make sure that you can get the data into the right places. So Nish spoke a bit about Watercare looking at building their own front end and their own APIs so that customers can access that data. I think that's a brilliant strategy. Ultimately, we want people to make better decisions, and to make these better decisions, we need to give them better data. And then technology, I think there's a lot to be said about technology. When we think about a very simple stack of, you've got a sensor talking over a network, talking to a cloud, those are all very, very big decisions, especially on the network side of things. There's a lot of options available. We've obviously taken the options that we believe is best and that will last, but you've got to think through all those things and make sure that 10 years down the line, that those decisions were the best possible decisions you could have made. And then people, I mean, like, let's face it, we talk a lot about the systems and the processes and the technology, but ultimately it's all people. You've got to make sure that that you firstly have the right people in your own team who want to change some things. We're very fortunate to have a bunch of people in our organization that just wants to change things. They want to change it for the better. So you need that core group of people that actually wants to change things and drive it through. But they also need to understand that they don't win when that project is finished. They win when the whole organization has come along on this journey and is across the line with it. So that change management process is really important. And then the last part about process, like it's ultimately, it's no good making a change and not having a control, right? So if we know, for argument's sake, that event A leads to outcome B, well, what can we do to control that outcome and to make sure that it consistently doesn't happen? Once off doesn't help. So, I think that component is really, really important. But, having said that too, it sounds a bit daunting. I was even listening to myself and I'm going, gosh, this is hard. But yes, it is hard, but it's tremendously rewarding. I think when we look at the savings that has been achieved in water. Nish mentioned a couple of figures there. We've had customers who saved 230 million liters of water just with 1,000 devices being deployed, and that's a massive impact. Being able to, at a time when we've got climate change, you look at what's going on in New Zealand. We had a very similar weather pattern over in Australia, where first we had the droughts, and then we had the flooding. So when we look at these things, there's no doubt that there's a lot of reward at the end of the process to be able to tell your friends or your family, hey, I'm helping to save water, I'm helping to make the planet a bit better. And that's not a boast. That's simply, making sure that you're in touch with your own purpose as a human being. So I think I sort of just want to encourage everyone who's on this journey is that, firstly, there are solutions. And to Nish's point, these solutions are also getting better. If I go back 10 years ago, most of the things we do today, we couldn't. There wasn't the networks around to enable us to do that. There wasn't the skills around, and the tools certainly weren't there to do it in an efficient way. And I just want to give you guys a glimpse of the things that we're looking at present as an organization. I think firstly, the advancement in AI. I've personally been looking at AI for, I don't know, 15 years probably. But what has happened in the last 2 to 3 months has just been incredible. We're talking about talking to a computer as if it's human, which and this brain being able to get solutions out that we simply can't do at the same speed. So I would genuinely encourage everyone to play at least with ChatGPT. As an organization, we've started bringing OpenAI immediately into the way that we work. So even things like job descriptions or press releases, we're busy using that. We're using it in our code. It helps you to advance the speed at which you can accelerate. So we sort of deemed that as, it's the abacus to the calculator. So we should get comfortable with the fact that using a calculator is better than using an abacus, and that's really what we're seeing in OpenAI. Sensors is really interesting. When we think about today, we're sitting with sensors where the sensor basically has one job description. So if we've got a carbon dioxide sensor, it only detects carbon dioxide. So some of the things that we're working on today is being able to take a sensor and give it multiple job descriptions. If we take cameras, for example, 10, 15 years ago, if you've got a Ring camera today, to have done that same thing on your front door where the camera can tell you there's a person or there's movement in front of your door, 10, 15 years ago, that would have costed you $5,000 to $10,000 just for that deployment. But because the camera's function is now digitally defined, there's machine learning that's telling it, this is a person, this is a cat, ignore the cat, there's a person at your front door. Because it's not digitally defined, we can use the camera in multiple ways for different job descriptions, and it doesn't just have to be security. We're seeing compliance, health and safety compliance being driven through cameras, and we believe the same thing's going to happen with sensors. The sensor industry has been very stagnant. There's not been a lot of changes over there, but today we're already seeing micro nano sensors that allows you to use the sensor as essentially a nose. So being able to see different reactions across the sensor array that allows you to reprogram that sensor into a multitude of different sensor technologies. And the reason you do that, it's the same thing as Ring cameras. It's ultimately, we believe that standardization will lead to lower cost. If we've got lower cost, we can solve more problems and make the world better. The last one for us is battery advancements. There's a couple of really interesting companies around. Battery still remains one of the biggest challenges for us, especially where we operate. There's not many power sources available. We're seeing that graphene is a really interesting new battery technology. After a long period of stagnation, that's coming around. There's a really interesting little company called Wiliot who uses battery-less Bluetooth to build what is called ambient IoT technologies, which ultimately, again, will lead to a place where we can, again, reduce the maintenance costs and increase the battery life. So those are the things that's top of mind for us as we look towards the future, how we can bring that into the products and how we can help customers like Nish on this brave journey of digitization. So I've said a lot of things. I'm happy to take any questions, but thank you for the opportunity, and thank you for listening to us.
I think our chance to thank you back, Gerhard. Thank you so much for your insights. Obviously, a great summary of what Kallipr's ethos is and the frameworks applied, but also some interesting insights into what's next. So very thankful for your time there, Gerhard, and your insights. I'd like to welcome Nish also back to the stage, as that wraps up our presentations for today. But before we get to the Q&A section, please can we see those poll results? Clicking to that section on the screen for myself, I can see that we're sitting on a fairly large majority, on 80% saying the way to solve future water crises is to manage existing resources efficiently, with the remainder suggesting new sources of water might be the solution, or through restrictions. So I think, Nish, if I can defer to you for your thoughts on some of those results, how does that stack up to your thinking?
I think that's what I would have expected as well, managing existing resources efficiently, because from a business perspective, it's cheaper to manage your existing resources than trying to find new source of water. Recycling and desalination, yes, it sounds very exciting, but it's very expensive. So if you can't spend money to manage your existing resources efficiently, there's no way you will find money to find new resources of water. So I think it stacks very well, and that's where the thinking's heading. You need to manage your existing resources before you start delving into recycling or desalination or finding new sources of water.
No, I agree. And I think the fact 0% responses to doing nothing as we have enough is a good way to prove people listen to pretty much the very beginning of your presentation.
Yeah.
So yeah, very good. And Gerhard, unless anything else from yourself you'd like to add on this one?
I just think it's a no regrets move. You know, even if you do find new resources, we still need to manage it effectively, and we need to reduce waste. So it feels like a no regrets move.
Yeah, couldn't agree more. Nice one. All right, team. Well, that moves us into the Q&A part for this session. So to everyone listening who still have a question burning on their mind, please review those already asked. If a question on your mind is already there, give it an upvote. If a question that's of particular interest to you is there, give it an upvote. Otherwise, enter it in. We'll be working our way virtually top down on those through that Q&A. So first one seems like it's coming to you, Nish, from Craig. It's asking what your advice is to the water utilities determining a start point for this digital journey, and what stakeholders need to be on that journey from the start. So your thoughts, Nish?
Yeah, I think the best starting point would be to find problems in your drivers. Understanding how much you're spending on those problems, or how much you're willing to spend on your drivers. If your drive is to save water, you don't want to look for another source. That's one of your drivers. If you, as a company or as a utility, want to be more water efficient or bound by new regulations, then yes, those are your drivers. If you have existing problems, like Watercare, one of the examples is what Watercare does is we have leak rebates for customers. So a lot of the customers who have private leaks, once they fix their leak, they get the excessive usage rebated back into the account or refunded. That's a lot of money we were giving to customers. And the only reason we were giving it to the customers is because we were not letting them know in time that they have a leak, because the billing is done monthly and the meters are read monthly or bi-monthly. So there's no onus on the customer of not finding the leak, because we were not able to tell them previously. But now with the smart meters and smart loggers, we can tell the customers within 1 or 2 days that yes, there's a leak, and they can get onto it. So there's no more onus on us to give the leak rebate back, and that's millions of dollars per year saved. So again, find your drivers and problems. Are you spending money on those problems? Can you utilize money, same money or less than that money, to fix those problems so that you don't have to repeatedly spend money on that? In terms of stakeholders, I would recommend getting likes of your customer team to engage with customers, your billing team to understand your billing problems, your operational teams to understand your operational issues for other loggers, and finance, and in the end execs as well. So once you engage the first 4 or 5 teams I advised, you will get enough material to stack up a business case to go back to your execs to show a good business value and get money for solving those problems.
And anything from yourself, Gerhard, on builds as to how that conversation might be on return on investment for Kallipr?
Yeah, well, look, I think there's also, I mean, I see Hirsch also asked a question around how long it would take to go through this, and so I think it ties into that, like ultimately, the technical / operational components of this is, it's relatively proven, right? We've got a number of use cases today across the world, which we can say, look, commercial metering, it works. We know it works. Nish has said to us that it works. It works elsewhere. Wastewater management, it works. We've got no doubt in our mind. So a lot of this actually has to do with the organization and where the organization is at. We've seen organizations that are very clear on why they're trying to do things. One of the water utilities we deal with has a strategy called Water 2033, which is awesome, because we know that they're driven to save the water, and they're ready for it. So I think from my perspective, is pick off the small little wins. Pick off the commercial metering is a very simple use case. It's not very hard to deploy. And sorry, I didn't. I'm comparing that to wastewater. So wastewater is just very, very difficult, and I wasn't great when we started with wastewater. But I think sort of from that perspective, picking those things off, you can easily go through trial to incubation. We've seen customers do it in less than 2 months. And then incubation to scale, we've seen customers 6 months. Whereas 5 years ago, you would probably talk about a year and then 3 years before you get to scale. So the fact that companies like Watercare and people like Nish has pioneered this field for us makes it easier for us to deploy it with proven use cases, as opposed to trying to figure it out every time. The figuring out will now happen. We'll move on to different use cases and refining things as we move along.
Yeah, appreciate those insights, team. Going through the question list, we have one from Tom. And Nish, this is, I believe, in relation to early into your presentation, you mentioned the need for a digital twin to view your infrastructure. Any more context or any more elaboration on that digital twin?
So for a water network utility, I think the digital twin is a digital representation of your actual network in the ground. The context is to manage water, you need to understand how your network is operating, how it's changed over time. A lot of the utilities have water models of the existing network, but in many cases, including Watercare, some of the models might be 10 years old. And a lot has changed since then. A number of customers you have has changed. The way you providing the customers has changed. The number of people in the household may have changed. So trying to get a lot of data points. And digital twins not just starting in this context as just metering. That's just one small aspect of digital twin for water utility. For water utility, you need to have likes of pressure sensors, understanding what pressures you have in the zone. You need to have all customers smart metered, understanding how they're consuming water. You need to have a lot of SCADA points which are constantly inputting data, what's being used in a zone over time, how it's changing. So some points could be live points, some points could be a daily input points, but you need to have a lot of data points or enough loggers in the ground so you have actual representation of how your network is operating on a desktop for someone like a water modeler who can understand how the network's operating and make informed decisions based on not just a theoretical model, but an actual model of how your network operates. So that's the context of a digital twin here for me, to get enough data points so you are very close to on a desktop of what your network's actually doing.
I think the only thing I'd add there is that, firstly, you've got all these multiple data points coming from different sources, and you can integrate them on a one-by-one basis, or you can integrate them in a digital setting, which if you think of something like flight simulator, that's a really good example of a real-time digital twin. And ultimately what you want this data to talk to each other in the same way that a traffic light system would talk to data points from Google Maps in terms of where's the vehicles, where are they going, and then ultimately beyond the operator, we probably see that some of those decisions being automated. If we can trust the data and the pattern well enough, there's no reason to have a human being sitting in the middle. We've got other things we've got to solve. So we've got to get onto them.
No, makes complete sense. I'm hoping for Tom that was what context he was looking for. But moving through the question list, we've got one from Hirsch there. Seems to be more of a collaborative industry question there for yourself, Nish, in terms of the other councils and water authorities that are across New Zealand. How do you know their progress with this similar technology?
So the ones that I know of, there's many utilities looking into smart metering, and loggers are something that's being installed for a long time by almost all the utilities to understand how the network operates. In terms of water metering, smart water metering, Christchurch looking into it, Wellington Water's looking into it, Dunedin City Council is looking into it, Waikato is looking into it as well. So these are some of the utilities which are slowly looking into it. As far as someone who's actually done it, I think Watercare is quite on top right now. We have installed almost 5,000 commercial loggers on commercial meters, smart meters on commercial meters, and we've also installed over 30,000 residential smart meters over the last one and a half years. So we're leading the pack right now.
Yep.
But all other utilities that I know of, I've spoken to, they are slowly trying to get into it.
Yep.
With the regulations coming, things might change. A lot of utilities who are not thinking of it might need to think of it to ensure they are compliant. So yes, this is just the start of IoT technology in waters. I think it's going to grow a lot in the next 1-2 years.
I think that that might prove a good point to swap to a question here. Oh, and it's just moved. No, there it is. You mentioned the certain regulatory side of things, and that's naturally on a lot of people's minds. But Anastasia is asking about the other major obstacles you find when working with customers implementing this water management technology. So I think in both cases, Nish, interested in your opinion here as far as the water authority implementing these, but also in Gerhard and your experiences with customers like Nish in deploying these technologies. So
from my experience, a lot of customers, we had a mix of, and you'll always have a mix of customers. Some people who want to adopt the technology and get the benefits out of it, and some who are not keen to get it at all. We've had incidents in the past, not many, also less than 5%, where someone's damaged the logger on the meter. And considering these meters are quite inside the property, it's quite obvious who might have done it. So we've had people who are damaging loggers and may not want anything to do with it, or may not want utilities to look more into or get live representation of what they're utilizing. Meters are Watercare assets, so legally we can. But there's also a lot of customers who are very keen to get it. So one of the examples I'll give you, I think that'll answer another question that was in the question list, which may not get enough votes, was, are there any examples are there any efficacies of using these loggers or these kind of loggers? So one of the example I'll give you is one of the schools, their property was on volcanic rock settlement. So the volcanic rocks are such where a leak doesn't come up to the ground, and sometimes it might flow underneath and disappear underneath the ground for a long time. So this customer had a leak of almost 60,000 liters a day. And if you look at the wastewater value of it and the water billing side of the things, your loggers paid itself off within 4 days for these customers. So there's many examples like that where leak might not be as big but smaller. But from my perspective, I think a lot of the times you may end up paying for your investment fairly quickly, especially for large commercial users.
That's a great insight there. And Gerhard, give you a little less time perhaps to answer, as we do have a hard stop for 12. But yeah, if you can give your most major obstacle you find when working with customers on these solutions.
But for us, the customer is slightly different, right? The customer for us is Nish and the utility. But I think sort of if I can answer it from that perspective, yeah, there's a lot of technology decisions. I saw there was a couple of questions about which network do we use. We use LTE networks as out of choice, so NB IoT and CAT-M1. That's typically one of the biggest challenges that we get. People want to discuss the network, and you go, well, the LTE network is paid for. Why stand up another one unless there's not connectivity? And I think sort of, so that's one. Also just internal resistance to change. And then look, like everyone, like in IoT or digitalization is sort of in this dial-up phase. We're all making mistakes. Wish we didn't, because they're costly and painful. But at the end of the day, being able to make sure that an organization has that continuous improvement mindset and understand that it's a bit of a journey at the moment, so but we're starting to see results, as Nish has said, so and that's the exciting part about it for us. So.
I appreciate that insight. No, thanks again so much for your time. I'm sorry for all those that ask questions. We don't have the time to get to them all. Might be Albert needs to be reached out from yourself, Nish. I think he's asking for a business case template, but yeah,
I'll quickly answer that. Look, business case documents do have some sensitive information which can't be shared, but more than happy to help of what things you need to add. And if every utility might have a different template for a business case. But I think looking for your problems, drivers, cost you spend on it, how much you can save by spending extra money on the loggers, they stack up a very good business case together as a cost-benefit analysis.
Yeah, I think we've had many examples throughout today of the ROI to these technologies, and they're fairly apparent nature. So again, thank you so much for your time, Nish Dogra and Gerhard Loots. So that's Nish from Watercare Services Limited and Gerhard from Kallipr. And those insights, I'm sure, are really appreciated by the audience today. And again, to all of you listening, if you'd like to find out more about IoT or other emerging technologies, please book your team in for a innovation studio tour at Spark. The link is being dropped into the chat right now. And just as we wrap up, I'd also like to thank you all for listening and for participating in the poll. It's been wonderful to have you with us today. And remember to check out the website spark.co.nz/IoT/webinar to see what other webinars are there, both past, present, and future. And the recording of this webinar will also be put up there shortly. So please do share that when it's there. And from myself and the Spark Innovation team, kia kaha, kia maya, kia mana wanui. Thank you.